when we're graphing an absolute value in 2 dimensions, we need to first decide whether or not we are graphing it with a solid line or a dashed line. Okay, like from Algebra 1 on the number line, were you doing with an open circle or a closed circle? That's what we had to decide. Well, just like in Algebra 1, if you have just a less than or a greater than inequality, that is going to give you the dashed line. Okay? Less than or greater than is going to give you the dashed line. All right. Now, for the solid line, that is our or equal to situation. So that's going to be if we have a less than or equal to or greater than or equal to inequality. Those get graphed with a solid line. All right? So that's it there. We graph the lines just like we always do, and we decide whether or not it's going to be graphed with a dashed line or a solid line, depending on what the inequality is. If the inequality says or equal to, it's going to be a solid line. If it doesn't, it's a dashed line. Okay? The other piece is that we need to decide where to shade. Now, on your notes, the shading didn't show up very good from the photocopying, so you might want to make sure to shade those sides so that you remember that we are supposed to be shading our answers here in our notes. But think of like the border between 2 states or the border between 2 countries. Okay, you have obviously like Iowa and Nebraska here. Iowa's on that side of the river. Nebraska's on this side of the river. Okay, so the river is then our boundary. Well, that's exactly what we're doing here. Whatever graph we're making, either a line or an absolute value, that line is our boundary. So this is going to be our boundary, and then all the solutions are going to fall either on one side or the other side of that boundary. Okay? We always shade the side that has our solutions. Okay? The shaded side is the one that holds all the solutions. And it's always going to happen where one side has the solutions, the other side does not. That's the way it always works. You can't have both sides not have a solution. Okay? One side has the solutions, the other side does not. So, how do we decide which side has the solutions? Well, to do that, we use a test point. Now, a test point can be any point you want as long as it is not on your boundary line. Okay? So that's the thing. Test point cannot be on the boundary line, but you can pick any point you want otherwise. Okay, there is no specific, you got to pick this point every time. You pick any point you want. Okay? Now, you take that point, you plug it back up into the original inequality, and you solve it. You find out what it gives you. If it gives you a true statement, you shade that side. If it gives you a false statement, you shade the other side. Because we always shade the side with true solutions. Always shade the side with true solutions. Okay? Now, do an example here to show you exactly what we mean by that. All right, any initial questions? There are 2 new things to what we're doing today. Deciding if it's a dotted line or a solid line when we graph the boundary, and deciding which side to shade. Okay? That's the only 2 new things. Let's look at the example right below this. All right, right below this we have y is less than or equal to 3x minus 1. Is this a line or is this an absolute value? It's a line. How do you know? Because there's no absolute value. That's all there is to it. Okay? There's no absolute value, so this is going to be a straight line. So, and also notice it's in the form y equals mx plus b. All right? We treat inequalities exactly as we do equations. Okay, so this is just looking at that. It's like y equals mx plus b. So where's our y-intercept? Y-intercept is at 0, negative 1. What's our slope? 3 or 3 over 1, yeah. Okay, so the next thing we have to do is graph our line, but we have to decide if it's going to be a solid or a dashed line. We got to look at the inequality. It's less than or equal to solid line. All right, so going to our y-intercept, count our slope up 3, right 1. You also want to graph the other side, so down 3, left 1. Make sure you graph your points all the way across the coordinate plane. And we are going to graph this with a solid line. Okay, so we have our boundary. Now we have to decide which side to shade. So we use a test point. Pick any point you want. Any point you want. I know, looking ahead, that I'm going to end up taking 3 times whatever my x value is for my test point. So I want to pick a test point that has, excuse me, 0 as an x coordinate, such as the coordinate 0, 3. Okay? So, picking any point you want, the only thing it can't be on your boundary. So plug that into the original equation. 3 is less than or equal to 3 times 0 minus 1. 3 times 0 is 0. So 0 minus 1 is negative 1. So they're saying 3 is less than or equal to negative 1. No, that's not true. That's false. So because that's a false statement, we then shade the other side. In your half planes here, one side of the graph is always going to be true, the other side is always going to be false. So we found the false side, so therefore we know the other side is true. Let's try another example. Taking a look at the next one here. Again, we have a line, so again we know our y-intercept is going to be located at 0, 1. I see that our slope is going to be negative 2, or you can think of that as negative 2 over 1. And looking at the inequality, this one's going to be graphed with a dashed line, because it is just less than, not less than or equal to. So we go to our y-intercept at 0, 1. We count our slope down 2, right 1. And you want to bring that all the way across your coordinate plane. You also want to do it in the other direction, so I'm going to go up 2, left 1. Going all the way across. And this is going to be with a dashed line, so we connect the dots here using dashed lines. There's our boundary. Well, again, we want to pick a test point. Any test point anywhere will work. So I'm going to pick this guy here. So I'm going to test 0, negative 2. So let's plug that back into the original inequality. I have negative 2 is less than negative 2 times 0 plus 1. Well, negative 2 times 0 is 0. 0 plus 1 is 1. So negative 2 is less than 1. That is a true statement. So that means we have found the true side of our graph. And so we shade the true side. I want to start with the one in the bottom left corner. That's what I meant. Thank you. Bottom right corner. Okay? So, looking at this one, is this an absolute value or is this a line? Absolute value. What's our graph going to look like then? It'll be a V. How do you remember it? Because it's absolute value. Makes a V-shaped graph. You'll never forget it. Okay? So, absolute value, we need to find our vertex. 3, -2, just like we were doing yesterday, right? A gives us the slope of the right side. What's A? 1. Okay, and one more thing. Looking at this, this is actually an equal sign here, right? That's a typo. Change that to less than or equal to.
Why is less than?
Change that to less than or equal to. It's a typo. All right? So we have found our vertex. We found our slope of the right side. We now look at that inequality. Do we shade this with a dashed line or a solid line? It's solid because it's or equal to. All right, so we graph. We go to 3, -2. The slope of the right side is 1, so up 1, right 1. And remember, absolute values have an axis of symmetry. So all the points on the right side there need to get mirrored to the other side. Okay, so we go ahead then and graph this with a solid line. All right, so there's our absolute value graph. Now we have to decide where to shade. Our options are either inside the V or outside the V. So pick a test point, any test point you want. You sure could pick 0, 0, yep. I'm going to pick, what is that point? 7, 0? No, 0, 7, excuse me. I'm going to test 0, 7. Okay. So, you go back to your original inequality. So I have 7 is less than or equal to the absolute value of 0 minus 3 minus 2. Well, 0 minus 3 is -3. The absolute value of -3 is 3. 3 minus 2 is 1. Oops. Give me a moment here. I goofed. All right. So 7 is less than or equal to 1. Well, that's false. So inside are all the false answers. All the true answers then are on the outside of the V. Questions? Please ask if there's something you don't understand. No? Feeling pretty confident? Okay, let's do one more. Go to the one in the upper left. The first one on the page. Okay, now, looking at this one. Again, we're going to have an absolute value graph, so therefore our graph is going to look like a what? A V. Okay, so we need to then go ahead and make sure that we can graph this guy, which right now we can't. Because right now it's not written in the form we're used to. What do we need to do? We have to subtract 1 from both sides. So we now have -y is less than the absolute value of x plus 2 minus 1. Well, there's still an issue here. So we've got to get rid of the negative out in front of the y, so we've got to divide everything by a -1. But hold on a second. Hold on a second. Please remember back to Algebra 1. In Algebra 1, you learned that you treat every inequality just like an equals, just like an equation, except when you multiply or divide by a negative number. Right? What happens then? Do you remember? No. You flip the inequality. Do you remember why? Were you ever shown why? You might have been. You probably were. Just don't remember it. Let's start out. That was a long time ago. Exactly. Let's start out with 1 and 2. So which one's bigger?
2.
Okay, so 1 is less than 2, right? Right. What if I multiply both sides by -2? So -2 times 1, -2. 2 times -2? -4. Which one's bigger? Oh, -2 is bigger than -4. -2 is bigger than -4. Okay, so we flipped the sign. What if I divide both sides by -1? Well, -2 divided by -1 is 2. -4 divided by -1 is 4. Which one's bigger?
4.
The sign flipped again. If you multiply or divide by a negative number, you have to flip the inequality. You can add and subtract all day long. You can multiply by any positive number, and it will not change the inequality. But if you multiply or divide by a negative number, it flips the inequality. So, looking back at the problem we are currently working, if we divide both sides by a -1, we now have positive y is greater than negative absolute value of x plus 2 plus 1.
So when you divide by 1, it doesn't do anything to the absolute value?
No. Basically, you're thinking of there being a 1 out in front of here already, and 1 divided by a -1 gives you a -1. And so you just have the -1 sitting out in front now. All right, so where's our vertex here? -2, 1. What's the slope of the right side? -1. So we go -2, 1. Slope of the right side is -1, so I'm going down 1, right 1. Mirror those to the other side. Down 1, right 1. And looking at our original here, are we graphing this with a solid or a dotted line? Dotted or dashed, yes. So graph this with a dashed line. Okay, well again, we got to pick a test point. Sure, 0, 0. Because we can tell that 0, 0 is definitely outside the V, right? So, always plug into the original inequality. Because what if you forgot that rule from Algebra 1 and you didn't flip the inequality? Now you're going to get the wrong answer. Okay, so always plug back into the original. So if we plug in 0, 0 as our test point, we have 1 minus 0. We'll have 1 minus 0 is less than the absolute value of 0 plus 2. Going back from the original inequality. So 1 minus 0 is 1. And 0 plus 2 is 2. What's the absolute value of 2?
2.
Is that a true or a false statement? That is a true statement. So therefore, all of our solutions fall outside the V. Any questions on this? Again, the graphing part is the exact same thing we've been doing for a week and a half now. The shading is new. All we do there is pick a test point. If it works, you shade that side. If it doesn't work, you shade the other side. We also have to decide whether or not we're graphing a solid or a dashed line. And that comes from the inequality. Less than, greater than, those are dashed lines. Less than or equal to, greater than or equal to, those are solid lines. Okay?